Hello everyone, welcome to Frontline Systems webinar on simulation and risk analysis in Analytic Solver, an overview of latest features and enhanced modeling support with an AI agent. Today we will focus on Monte Carlo simulation using Analytic Solver, our all-in-one product. Starting with a simulation model for a tech company, I will show you what you can do within and beyond Excel with an overview of recent and advanced capabilities of Analytic Solver. If your model is at risk, which is limited to only Excel for Windows, it is time to consider taking advantage of Analytic Solver and its capabilities. This power is only one click away. Together, we will convert an at-risk model to Analytic Solver and access all its possibilities within and beyond Excel. For example, I will show you how you can create a cloud service from the converted model, and then how you can immediately with one click create a web application. Furthermore, we explore our AI agent for modeling support and enhancements. Analytic Solver offers an AI technical support agent based on same technology as ChatGPT, and it has studied thousands of pages of frontline help and user guides. Everything about optimization, Monte Carlo simulation, and other features of Analytic Solver are available, and it is available for you to utilize. As time allows, if you are interested, I plan to show an example of fitting a distribution to historical data and show you how you can promote this distribution to the cloud and share it with others. Analytic Solver is an all-in-one solution. This means that it completely equips you to model and solve deterministic and stochastic optimization models, model and run Monte Carlo simulation and risk analysis, employ decision analysis with single stage and multi-stage decision trees and decision tables with full compliance with DMN rules. Moreover, it enables you to perform data visualization, forecasting, text mining, machine learning, and other predictive analytic capabilities for large data sets. Analytic Solver runs on Excel for Windows, Excel for Mac, and Excel for Web, and it works very well with Microsoft Teams, and also it has other features that we'll talk about, how to go beyond Excel with point-and-click deployments of models to Power BI, Tableau, and much more. But this is just a starting point. I wanted to give you an overall picture of our product line. We offer much more, including our platform called Raison Decision Services, Solver SDK, and Excel Miner SDK. Raison is our cloud platform offering decision analytics for Microsoft Cloud that offers a REST API. We'll get familiar with Raison today. It works very well with Analytic Solver. Solver SDK and Excel Miner SDK, they both offer high-level APIs for with the language. They both work in C++, C#, Java, Python, or R. And Solver SDK is for prescriptive analytics. Excel Miner SDK is for predictive analytics. This was just an overall picture of product line. Let's focus on Analytic Solver and its capabilities for Monte Carlo simulation risk analysis. So let me open our fixed example. This is a very simple, straightforward simulation model. It is already 90% completed. This is a startup tech company. They have a great idea for a new software. They want to create a simulation model that helps them estimate both the time and cost associated with the new software development. If you look here, there are development stages. These are the development stages. And it's broken down, for example, to market and asset design and so on. Based on their research, they have estimated the number of weeks required to complete each stage using a most likely best case and worst case scenarios. Accomplishment of project can be delayed due to various events such as bad design, employee sickness, vacation, and much more. Here they have the list, and there is a probability of each event listed here in column G. They also have the number of delay in number of weeks based on, again, most likely, best case and worst case scenarios. Delay is costly, so there's the associated weekly cost. They calculate the total cost due to delay, factoring the event occurrence and estimation of number of weeks. Same way we calculate total development stage total cost, right? So it's just multiplication of associated weekly cost by estimation of number of weeks. But we have to complete some of these cells. So we have a total estimated total cost in cell K35, adding both of the costs, and also we add up all the estimation of number of weeks and add both of them together in cell I35. So these are the calculations. So we want to use Monte Carlo simulation to estimate the total cost and required time to create the new product. So our outputs are clear. Now, if you want to build a simulation model from scratch, you need to use the simulation model tab. So let's go to Analytic Solver. This is the simulation model tab. So everything you need to build your Monte Carlo simulation model from scratch. First option is distributions. This allows you to access a range of predefined probability distributions. You can select an appropriate probability distribution and parameters to model the uncertainty of each input variable for your model. You have access to MetLog family of distributions. We will talk more about MetLog distributions once we work on fitting a distribution. How do we use this distribution? So we have sources of uncertainty. Here we have to estimate number of weeks. So we can do that with one of these distributions. Since we already know most likely best case and worst case scenarios, we can use triangular distribution. If you are not sure what to use, you can always use distribution wizard. It asks you questions and step by step helps you to narrow down choices and helps you find out what distribution to use. You have to decide whether it's discrete or continuous, and we continue, and it then asks you whether it's bounded or unbounded and helps you find out what best can model your source of uncertainty. If you have historical data, you can fit an analytical distribution to your historical data. Also, you can use the historical data randomly or sequentially. All of those options are available. Let's go to distributions again. We're going to go to common distribution. Triangular is one of the common distributions. You can find it on the shortcut list. Click on triangular. Here you have to adjust the parameters to point to the values that we have in this cell. We call this an uncertain variable dialog. We have a PDF tab. You have a CDF tab, you have a reverse CDF. On the right side, you have parameters. Also, there's a drop down for analytic moments, percentiles, chart options, access options, and much more. So PDF, CDF, reverse CDF. You can make it three-dimensional. And now on the parameters, let's adjust the parameters to point to min, max, and likely. Min, max, and likely, we point them to worst case, best case, and worst case scenario for development stage market analysis. So min is best case, right, shortest. And the reason this chart is not being shown is because minimum, which is 8 currently in this cell, and we put 8 here, and then we have most likely and max. So minimum is greater than most likely and max. That's why it's not showing. But once we change everything, it will work just fine. Most likely 12 in cell C15, and max is in worst case cell E15. Once I adjust everything, here is the chart. And once you click on save, you will have a triangular distribution with these 3 parameters. And check it on the formula bar also. Okay. Let's quickly repeat for this, for bad design, same thing, distributions, triangular. So this is how you model your source of uncertainty using Analytic Solver. Let's quickly adjust the parameters. I can start from max this time, worst case. So you can see the chart keeps getting updated, most likely 8, and minimum is in best case. So D26 and click on save. You can induce correlation among your uncertain variables. You can use results button to calculate the statistics, range values, and much more. So you can use correlations, you can use results button here, you can calculate the statistics, range values, Six Sigma matrix, and much more. If you want to know how much money might you lose with 5% or 10% probability, you can use quantile measures, or what's the probability that you will make at least a certain amount of money, okay? There's PSI target, which returns the proportion of values less than or equal to a target value, and much more. You have confidence intervals. So now let's go back, finish the modeling. And then the event occurrence, we have to model that, to model the occurrence of each potential delay. And here we are using a Bernoulli distribution, okay? So select an empty cell, let's go to distributions. This is a discrete distribution. The first one, Bernoulli. And we have to adjust the only parameter it has, which is the probability, okay? So here's the probability. We have to adjust this and point to the probability of this event, which is 20%. And click on save. So in this cell, we have a sum formula to calculate total time, and then we have the sum formula to calculate total cost. These are the two outputs of interest. And we have to tell Analytic Solver these are our outputs to record over the simulation trial for us. So last step is to mark these cells as output. One way is to select the output formula, go to results, output, in cell. Okay, and it designates the currently selected cell as an uncertain function, and it adds a psi output to the function. Another way is to calculate, for example, a summary statistic. For example, if you calculate average number of months or any of the other results button calculations, and that will make sure that once we have to do, for example, the average cost, then it automatically needs to calculate, record over all the trials for us. So either mark the cell as output or do some kind of summary statistic. By doing this, we are ready. We can execute simulation for a number of trials. So let's go to simulate on the ribbon, run once. And here are the results. So I-35 and K-35. We just ran 1,000 Monte Carlo trials, where on each trial we have a different randomly sampled value for delay for each stage and event. Then we calculated total cost and total time. This frequency chart shows the distribution of all possible outcomes for our total cost, which is this one, K35. So you have a summary here, and also you can look at the statistics. What is the mean? What is the total maximum and minimum? You can look at percentiles, you can look at Six Sigma measures, and much more, okay? On the top, you have frequency, cumulative frequency, reverse. You have sensitivity tab that shows you a tornado chart showing you which input has the most impact on this output. And then you also have individual scatter plots. Now, let's look at total time. So the total time for this project can be anywhere from 50 weeks to 98 weeks with an average of 72 weeks. So let's close this. And I requested some site data, getting all the 1,000 trials for total cost and total time. And that's why you see all these numbers down here, okay? Okay, now, this is our first simulation model. You see it's very straightforward to define your simulation models. Now let's continue. On the model dropdown, you have additional options for multidimensional modeling. This tool is helpful when you are building larger models, when there are multiple products, projects, or investments or time periods. You have multiple sources, multiple destinations, and then dimensional modeling helps you turn a very complex, hard to maintain spreadsheet problem into simple, well-structured, easily maintained, and expandable model, and it works great with pivot table. So if you're interested in the user guide, and there are some videos that you can learn more about dimensional modeling. Then the next group is optimization tab. This is everything you need to set up your optimization model. You can solve large scale optimization problems with or without uncertainty. We will have a separate webinar on optimization, and we will feature stochastic programming. Analytic Solver offers a state-of-the-art technology for stochastic programming and robust optimization. And we also have the fastest performance in simulation optimization. And we also have the unique capability to define and solve problems with wait and see or recourse decisions. So if you're interested, it will be in 2 weeks, our webinar specifically on optimization and stochastic and deterministic optimization. There is a specific webinar focused on decision models. If you're interested, look at the webinar link, educational webinars. Parameters tab allows you to build a multiple parameter simulation. With Simulate, you can run simulation. There's much more. You can run interactive simulation. We don't have time to go over it today, but again, there are videos and also educational documents on this. Optimizes for solving optimization. And now our next focus on is on model deployment. We use Analytic Solver to create and run a simulation model and get results. Now, how can we easily share our model and its results with others or other users in a repeatable and manageable process? I have a quick question for you. Are you sharing your model results using PowerPoint or by emailing copies of your spreadsheet? What if you change the model? Do you send a new email? And in this part of the presentation, we want to discuss this, and we want to go over advanced capabilities of Analytic Solver to enable you to share your model to be used wherever and whenever it is needed. You can achieve this by using a cloud service, and it's by calling Raison, a Raison server. Remember, I told you we have another product line, Raison. But the good news is that you can do all of this, and you can deploy your analytic models to the cloud, to the Raison, entirely within Excel, and check runs of your models. Here you see there's the option to manage models. All of this without leaving Excel. So no code. So with these tools, you can deploy your model and turn an Excel model into a cloud service in seconds. Now, they have different options. You can host your simulation model in Microsoft Teams. You can embed your model, create a cloud service from it with the translation to Raison language or just the Excel workbook. You can embed model and solve it by Power BI. You can use Tableau. You can create your own application with Solver SDK. Remember the other product that we have. And you can create a web page with just a few clicks. All of these options allow you to make results conveniently available to others. This is what we call model deployment. So we are going to practice a few of these options as time allows. Starting with Teams. To use Teams correctly, make sure the first step is to save your workbook to a location that is network accessible, such as OneDrive or SharePoint. I'm going to turn on autosave, and it allows me to save a copy of this model in OneDrive for frontline systems, okay? So we are going to share our interactive model results without sending the whole workbook. We send the report through Microsoft Teams containing interactive links to original workbook. And we can choose exactly what part of results we want to share in that workbook. So step 1, we want to make sure model is network accessible. Step 2, We want to make sure model is solved and Teams is active. So if you go to Teams and it's grayed out, it means you need to resolve the model. Okay, so let's close this. Let's run simulate run once. I quickly close this and this one. Now let's go to deploy model Teams report. Let's click on that. This is the first dialog where you can select the model components to include in the team report. You can use outputs, you can use inputs, and I'm just going to click to choose everything. Okay. Let's click OK. And then there's another dialog that will pop up. Here, we have to select the team and channel where you would like to share the results. For example, we have two teams. I go to test team, and channel, I go to general. Let's give it a name. Let's call it webinar Teams report. And the message we're going to send to our colleague is, hi, please review the recent version of the model. And then click on send. Multiple things happen. And when it's completed, a message will appear reporting that the report was sent successfully. And here's the message. So during this time, Analytic Solver automatically created a new workbook called Sim Teams Report, Simulation Teams Reports down here. Okay. Let me show you what's in this workbook. And this is just the results that we selected to share. Okay, it's only model results with external links to model workbook. Now, this Teams report has dynamic links, and if we go to Teams, we can see that it's shared with our colleague in that channel. Okay. So let me open Microsoft Teams. So I have different, you can see groups, testing. Under test, we go to general. And if you scroll down, this is the model that we just shared, right? Hi, please review the recent version of the model. Once I click on that, okay. So we just have to enable content so that all the numbers are represented there, and exactly the same report that you saw in Excel. Okay. So this is our Teams report. Your colleague can now see your model results in Microsoft Teams. If any parameter changes on the original workbook, you can simply resolve the optimization or simulation, then click the refresh icon on the workbook, and there is no need to deploy a new Teams report. Okay. Also, if you go back to Teams, you have the option to open this model. You can open it on Teams, you can open it on this Excel desktop, or you can open it on Excel online using your browser. So if they don't have, they can use either of these. So your colleague now using Teams will be able to open the workbook, view, copy, or work with the results that you are providing without sharing the whole model. And once you read on, it will automatically get updated. This is just an example of what can be done. You're invited to customize this report to the design of your choice. There is only need to generate the Teams report one time. So this was our Teams example. And let's look at the example of Power BI. So we are going to create a custom visual from our simulation model. Our goal is to quickly call a model on Raison server using Power BI and display the results in Power BI without any code. Okay, there are two ways to do it. You can generate a Raison equivalent of model embedded in a custom visual and run the model on the server and display the results. Another way is to actually post the model to Rayzon and then directly call it from Rayzon, okay? So let's click on deploy model. Let's click on Power BI. I'm going to show you embed model option, okay? Now, in this part, we have to give a name to this model. We are going to post this model to Rayzon Cloud Service, and we have to give it a name. Let's call it webinar. So then this file type is PBI Viz, Power BI visualization. Let's click on save. As soon as I click on save, you will see that two command prompt windows will appear on the screen. It takes a few minutes, but eventually both will disappear. But during this time, our Excel model is being translated into Rayzon modeling language and your custom visual is created. Let me tell you that this option allows you to create a data well in Power BI which accepts input data. So if you look at that recording that's available on YouTube channel, let me quickly show you. I discuss all the details. So let's see this one. So it's the second one under educational webinar. And I'll show you example exactly how you can create data well and directly work inside Power BI, change that, upload new data and rerun the model. So this is almost finishing up. We have to wait for the two command windows to disappear. That's when the custom visual is completed. While this is working, let's explore the AI agent. So let's click on that. We're going to ask a question and see how the AI agent can help us. For example, you can ask us, what are the simulation, what are the Monte Carlo simulation modeling steps? Okay, you can ask a general question like this, or you can ask a more specific question. While this is running and gathering information for us, let's go back to Power BI, okay? Because the two command windows disappeared. So let's open a Power BI. I have a desktop version of Power BI. We have to import that custom visual to Power BI, the custom visual that we created, okay? There are two ways to do this. You can go to File, Import. You can see Power BI visual from File. But if you look at our user guides, we also show you another way of doing this. Under Visualizations, there are these three dots here. If you click there, there's option to import a visual from a file. Select that. It says it's an external file. That's okay. Now let's look at what we saved. Webinar 1122, right? Let's select that. This is our custom visual. Click open. It says the visual was successfully imported to the report. This is the frontline system icon that now appears. You just click on that. And now it is running the simulation on Rayzon server and displaying the results for you. Remember I-35 and K-35, these are the two outputs and these are all the other inputs to the model, okay? Of course, there's much more you can do, but this is just basically using the basic templates that we created for you, okay? Now, if you're interested, again, you can watch that video and learn more about what to do with Power BI and Tableau. This was how you can actually create a custom visual. Now, back to our Analytic Solver AI agent. What are the basic steps of creating Monte Carlo modeling, okay? And it gives us the answer, but also gives reference to Frontline System User Guide, exactly the pages that you can go and learn more about creating a Monte Carlo simulation model, okay? But this was a general example. You can ask more specific modeling questions. Just quick touch on task pane. So in the task pane output tab, you get a report of the simulation output. Okay, so you can see, so once the simulation finishes, you get successful trials. If there's error, it will actually make it red and show you. You have model tab that shows you different components of your simulation model. Okay, so under simulation, you have uncertain variables. We define them with the triangular distributions. You have uncertain functions and a statistic function. Uncertain functions were those two, total time and total cost. Statistic functions are like, for example, if you use average or percentile and anything else, okay? If you want to adjust some of the simulation options on the ribbon, there's a tab called Options. Click on Options, and this is the simulation option. You can change the number of trials per simulation, how many simulation to run, what is your sampling method, random number stream, and random number generation methods. If you run multiple parameterized optimization simulations, you can go to Tools tab and actually look at individual trials. You can actually cycle through individual trials and choose what trial to display. You can choose to display all trials, or you can choose normal trial, or just show the sample mean on the work. So let's close this example and open our next example, which is an at-risk model. This model is developed in at-risk, okay? And it is created by our consulting partner called Epix Analytics. If I show you Analytic Solver task pane, under simulation, you don't see anything defined, right? It's all empty under uncertain variables, uncertain function. The reason is they're using at-risk, right? So all the formulas are at-risk formula. I can actually show you. For example, it's called like risk PERT and everything, okay? All at-risk functions. I want to show you how we can turn this at-risk model to Analytic Solver and then use all the features that are available in Analytic Solver. So let's go to distributions on the ribbon. There is a button here called Convert. So let's click on that. And it asks, Solver will find your at-risk functions and replace them with the equivalent psi functions, PSI functions. Do you wish to continue? Okay. And conversion was successful. The solver converted 7 functions. Okay. Now look at task pane. We have uncertain variables, we have uncertain functions and statistic functions, the equivalent of the model instead of at-risk this time in Analytic Solver. Now, you can go ahead and solve this simulation model. Simulate, run once. And here are the results. We don't want to go into details of this model, but you can see that with just a few clicks, you converted the model. Now you're ready. You use the full power of Analytic Solver. Okay, now let's click on Deploy Model. I want to show you a few more of the deploy options with this converted model. If you are not sure what option in Deploy Model group to choose, click on Deployment Wizard. This is a step-by-step help, gives you information about the deployment options. And for example, I want to share my model on a cloud service that web and mobile app can easily use. Next, how do you do that? Go to Cloud Service, Excel Model, now and gives you all the details. You can click on Try It, or you can go back and choose another option. Let's practice some of this deployment and let's promote this model to sit on Rayson Cloud Service. Okay, so let's create a cloud service from this converted model. Let's go to Deploy Model, Cloud Service. First time, I want to show you how you can translate the model to Rayson and post the model to your Rayson account. This is my Rayson account. You can give it a name here and click on Save. Automatically, Rayson.com will open up. The whole model, that at-risk model that was converted to Analytic Solver, is now translated to Rayson modeling language, which is in JSON. Okay. Here you have the model automatically translated for you. You don't need to write any code. On the left side, these are all the models I have under my account. Excuse me, I'm going to mute myself for a second. Oh, sorry about that. Okay. So we save a copy of our model in Rayson server, but it's translated into Rayson modeling language. This is the code. On the left side, these are all the models I have under my Rayzon account. This is not Rayzon server. What you see here is Rayzon.com, which is a front-end portal to Rayzon server. Okay, we created this. This itself is an application that works with backend server. We created this to make it easy for you to see what's going to happen and, for example, see how you can solve the model and get the results. Okay, so I clicked on solve. Now the model will solve on Rayzon server, and the results will be displayed here for us, the simulation model. Okay, once it is complete, I can choose to, for example, see the statistics. The results are available in two formats, OData and JSON. Okay, so this is the OData format, and you can actually, let me highlight this, click on this button to convert the results to JSON syntax. Okay, all the results are available in also JSON syntax. There's much more you can do here, but let's keep it simple. We started from Excel, we promoted our model, we created a cloud service from our model. Now, let's repeat the same step. This time, we are not going to translate the model. We are just going to post the Excel workbook itself, promote it to be a cloud service. So I just use Excel option. Your workbook can reside on OneDrive. Let's click on save. Same thing happens, but this time you will see after a few minutes it's different. It didn't get translated to JSON syntax. It's the Excel workbook itself, okay? But you have all the other options. You can solve the model, get the results back, and results are available here, okay? Just solved it quickly for you. Let's show you one more option. Let's go to deploy model, quick test, web page. This time, Analytic Solver automatically translates the Excel model into Rayzon. Here's the Rayzon translation of model. This is the HTML web page. It created this web page for us with some text box and buttons, and the Rayzon translation of model is here. And everything is embedded in JavaScript on this web page. So this is the working version of model that runs on the web. If you click on solve, you have this Ajax call, you can click on solve. From this web page, you connect to Rayzon server. It solves the model and displays the results for you here. So the model is automatically submitted to Rayzon server. Simulation is started. Once the status is checked, results are back. Results are displayed here in JSON syntax. If you are interested to learn more about using this for creating your own application and web application, you can look at view page source. Here we show you have everything you need. We're using HTML to create the form, buttons, and then if you go down, this is the model itself in JSON syntax, and we show you how you can communicate with the server to get the results. Everything self-contained. So you saw that we created a web application from our model, which was initially an at-risk workbook with just a few clicks. This ability in Analytic Solver includes bypassing months of development work for you. I hope you enjoyed it. Let's look at our last example for today. As I promised, I'm going to show you a fit option example. Let's click on help. Under help, you can access to user guides, Analytic Solver user guide, Analytic Solver reference guide, lots of information, examples to master simulation optimization concepts. Furthermore, here you have access to example models. You have access to example models that are categorized based on Analytic Solver features. We are going to look at simulation, Monte Carlo simulation examples. And we are going to look at college fund growth because it has a sample data that I want to use. But let's go back to help one more time. You can also go to education and training and connect to Solver Academy and some video tutorials, live webinars, and much more. Just use the few minutes that we have and review the fit feature. I'm not going to go through details of the model, but let's just select this is the S&P 500 annual return data. And I want to show you how you can, for example, fit an analytic distribution to this sample data. So let's select the data and go to Tools. First option is Fit. So in this Fit Options dialog, you can leave both selected for distribution type. So we have classical distributions and we also have the family of meta-log distributions. Let's choose both so we can compare them. Meta-log family of distribution can closely approximate virtually any classical continuous distribution, and they often fit user data much better than classical distributions. So Analytic Solver gives you full power to use bounded and unbounded and multi-term meta-log distributions. So let's keep that. Sample data is selected, continuous is fine. You have distribution options. You can keep the check allow shifted distributions, and this allows Analytic Solver to shift the center of analytic distribution to better fit the sample data. So when fitting a sample to a distribution, it is important and trial values are not correlated with each other. If you want to run an independent test, you can actually check and run a sample independent test. I actually did not use the allow shifted distribution, so you can have goodness of fit test and just use the default. Let's look into meta-log distributions. Max term selected is 16. This is the number of terms in the meta-log function. Minimum is 2. You can allow to run bounded, unbounded, but you need to set the bounds. Let's enter negative 0.05. This has to be smaller than any data point in the data set. And 0.6 for the upper. And the upper bound should be greater than the biggest number, right? Now let's click on Fit. Analytic Solver computes and displays a ranked list of candidate fitted distribution in front of us, okay? Initially, the distribution with the best fitted statistic is shown in the chart that overlays the sample data. We have a meta-log with 14 terms. It's kind of overfitting the data, but we don't want to get to the details of that, okay? I just wanted to show you one example. But the next one is a meta-log with 6 terms, okay? So we have a bin bar here down. You can use to kind of add or subtract number of bins in the histogram. So on the left side is a list of fit choices shown in descending goodness of fit based on the test you choose, okay, that we have in the left side. You can select multiple choices and compare all of them together. You can also click on this is the comparison chart. On the top, you have the PP, QQ, CDF, and meta-log panel. So PP is the probability chart. This graph is used to determine how well the specific distribution fits the observed data. The chart will be approximately linear if the specific distribution is the correct choice, okay? So you can actually use that. You have the quantile chart. You have the cumulative distribution function difference chart. And let's look at the meta-log panel now. We see all feasible meta-log density functions. And again, the larger the number of terms, the greater the possibility that distribution may overfit the data, okay? So now you can actually close this and click on Save and save it in one of the cells. For example, let's save it in cell K1. So we have saved this meta-log distribution with 14 terms, okay, in this cell, K1. Now I want to show you what you can do from here. Imagine this data is confidential and you cannot share the whole data with someone, but you want to make your colleagues able to access this meta-log distribution, this fitted distribution. So you can actually promote this meta-log distribution to sit on Rayson server under your account, and then they can import it in their workbooks as a distribution, just like this, the distributions here, and then use it. Okay, let me show you in just few steps how you can do that. Let's click on Deploy Model, Cloud Service, probability model. Once you do that, select the available distribution in K1. That's the one we want to promote, right? So click on Add to move it to select a distribution. The library name is College Fund Growth 1 Simulation, and click on Save. Once you do that, just like what we did with the model, it promotes the distribution. Have it in Rayzon server, and you will see in a few minutes a copy of the distribution. Okay, everything will be translated to JSON syntax for you. Okay, here's the mathematical distribution with all the coefficients. Okay, it is sitting on Rayzon server under your account. Now, imagine someone wants to create a new model and they want to access this metalog distribution that you have posted to server. Let's go to distribution, click on import, and it will give you all the probability models. I think it was College Fund, right? And it is the distribution in K1. Let's paste it in cell A1. Just like a normal distribution, now your colleagues or yourself, you can access the distribution, this MATLAB distribution with 14 terms, and use it for building their simulation model. This concludes what I wanted to share with you. Let's have a recap. This is a visualization of what we practiced today. We started from Excel with a model that we developed Excel. We used deploy options to create a cloud service from the model, meaning we promoted the model in 2 versions to Rayzon server, which is an Azure hosted platform. You also saw how Rayzon.com as a front-end portal show us a copy of model. We were able to communicate with Rayzon server, solve the model, and get the results. We also saw how we can do the same thing with a web application. Now the models are promoted and we have a cloud service. It's really easy to have a web application and communicate with Rayzon server and get the results and display them in the web application. We also show you an example of Power BI, how Power BI can easily work with Rayzon server. All of these are possible. All of these clients can work very well with Rayzon server. You can create your mobile application, web application, use Power Apps, all possible because of the power of Rayzon. Okay. Excel would make it easier to get started with analytics. And remember, Analytic Solver runs on Excel for Windows, Excel for Mac, Excel for the web, and works well with Microsoft Teams. And let's skip this. Analytic Solver offers all the tools from convenience of your browser as well. Today, we explored 2 key components of our product line. One was Analytic Solver. We also learned a little bit about Rayzon. And we saw how we can promote our models to run them on Rayzon Cloud Service and make the results easily available to other people. We converted an at-risk model to Analytic Solver with 1 click. Then we created a cloud service and a web application from it with only a few clicks. These abilities to work with Rayzon and do much more are all yours, and they bypass months of development work for you. There's much more when it comes to Rayzon. You can create multi-stage decision flows with automatic scheduling. If you're interested, again, create an account on Rayzon.com and start exploring our products. I enjoyed presenting this webinar to you and trust that it was helpful. Here is our contact information. You're welcome to send any questions or comments to consulting@solver.com. This is my email, and also there are other emails for some of other key members of our team. Thank you so much. I appreciate your time. Next week, we are going to focus on data mining and machine learning. If a question comes up later, email me at consulting@solver.com. Thank you so much for your time and have a wonderful rest of the day. Bye, everyone.